Welcome to week 4 of cis204 Unix shell scripting and utilities. You've been through already a history of computing, personal history of Unix, Linux files and processes. You've seen the dreaded ed and have been exposed to VI. Let me warn you that you're going to be using VI quite a bit. Everything in the real world, the one tool that you know you will have access to as far as editing is concerned in a bash environment is Vim, the improved VI. And this week we're going to get into text processing. So let's jump right into it. Basic text processing. If you remember, I spoke of Ken Thompson needing a faster machine to play space travel on. And they needed to go to management to purchase this machine, and so they had to come up with some idea of how they were going to justify getting a machine that was faster than the PDP-7. Well, they wanted a PDP-1170, and the justification was that they could find a way to process text using the UNIX operating system. And so what they intended to do was sell this as a text processing tool, that Unix would allow them to search, do all kinds of fun things on text files and create text files. In fact, there's a couple of tools that we'll just briefly mention called nroff and troff. Runoff is the ROF part of it, and the nroff was new runoff, and troff was typographic runoff. What these tools were the nroff and troff were a way of typesetting documents using the Unix operating system, in this case tools that were built in the Unix operating system. And the labs produced a number of documents using these. In fact, the original C programming guide was typeset using troff, I believe. So the idea is that one of the very first things that Unix was slated to do was to do text processing. So we're going to jump into some basic text processing. Remember this thing? This is that teletype, that TTY35, and to be honest with you, I'm going to let you see a little bit of that teletype in action. Here we go. That's the paper tape reader you're seeing actually working with this thing. This is a Model 35 ARS or ASR. It has a tape reader and a tape punch. Let me go a little bit forward here and we'll get past all this Wizzo nonsense. Let's get to about here. We'll show you the actual tape punch. Now, doing a reader again. Here we go, the tape punch. Believe it or not, these paper tape spools were actually used to create what were known as broadcast warning messages for the local switches. Western Electric would create these little paper tape bundles, send them out to us, and we'd install them on the operating system. Basically, we'd read them in using this teletype. It would create an update. We would then insert a memory card into a card writer. And the memory card is a bit weird. One of these days you'll have a chance to see it if I can remember to display the thing. Nothing like you would imagine. But we'd write the memory card and insert it in the appropriate spot in the program store, and the generic would be updated. So let's move forward a little bit and show you the actual teletype in action. Here we go. I think the thing that is kind of important to understand is that this was all line at a time. And once you understand that it was line at a time, you'll understand why Ed was the way it was. A lot of these systems used this type of paper tape terminal, paper tape and paper output terminal rather than a screen. And these were common in computer setups with the PDP-1170, the PDP-7, and they were common in the switching offices in the 70s. We did have computer terminals, but they were few and far between. So this is where Unix grew up, basically. It grew up on paper output. So let me continue this a little bit and we'll go forward. But you can see all the mechanical monkey motion going on in this thing. Now we can get a close-up of that mechanical monkey motion here in just a moment. Maybe. There we go. And being in a room with one of these devices was awfully noisy. So the reason for the goofy line at a time editor ED is this machine. And once you understand that, and once you understand that there was no recourse to a GUI, a mouse, or anything else, that's why we ended up with text processing the way it is in Unix. So let me talk a little bit about character sets. There's UTF-8, the ISO standard, ASCII, which is a subset of UTF-8 and came before. There's an ISO 8859-1 that you're aware of that a lot of the Microsoft stuff uses. And there's other ISO character sets. Then there's an IBM standard called IPCODIC, EBC-DIC, that we'll talk about in a bit. But first, let me show you the character set in the CentOS environment. Let me do this. Let me clear out of this and do a uname-a. So this is the atscis.jccc.edu image. This is the CentOS image that you're using, and you're going to be doing all of your work on this image. Let me issue this command. It's called locale, and this will tell you what character set is in use for your login. In this you can see the character set in use is UTF-8. Okay, so that's why UTF-8 is what we're going to talk about. That is the default character set in this CentOS image. So U is from Universal Character Set plus transformation format. It is an 8-bit character set, 0 through 255. ASCII, which came before UTF-8, occupies codes 0 through 127, which means, for all practical purposes, that UTF-8 is just an expansion of the original ASCII. Here's the fun piece. Ken Thompson and Bell Labs had their hands in it and made it first work. this UTF-8 character set in that Plan 9 from Bell Labs that we've already talked about. So what is ASCII? American Standard Code for Information Interchange. And here you can see an ASCII table. It was this thing is available here, this dgrave.com reference, and let me go to let's see here. Do I want to go to the UTF-8 table? No, not yet. Let's call this thing up for grins. So do that. Get this. We'll paste that. So this is the ASCII table. Okay. Look at this little odd duck thing. Bell. What the heck is that for? Well, if we go back here, there's a bell on the teletype. The bell is there to warn you that something's going on. In fact, look at this. This message, warning, and bell system. Okay, so null, start of header, start of text, end of transmission, inquiry, acknowledgement, bell. Those are all things that were there because this was written for the transmission of information on these goofy terminals. So that's the reason you have stuff like that. Now the other fun thing to note is that the character set starts here at a decimal 65. And there's an octal version of that. So here we go to 65. It's an octal 101. It's a hexadecimal 41. So the capital A, right? If we go to an octal 41, it's a exclamation point. And we'll talk about that later. So here you have in this ASCII character set, starting at 65 decimal, the uppercase alphabet. Then there are, and it's contiguous. Then there are a number of punctuation pieces. And then you see, starting at decimal 97, the lowercase alphabet. And finally, the last thing you see is 127 is delete. Okay, so the UTF table is an expansion of that. Basically, there are another 128 characters that are available. So again, the encoding is variable length, uses 8-bit code units. It's backwards compatible with ASCII, and that's because those first 128 characters, 0 through 127, are a direct copy of the ASCII character set. 128 through 255 are the UTF-8 edition. So here we go. There's some odds and ends that you want to look at, but here's the basic layout. Notice we've got all the way to delete, and then we have all of the additional characters that can be put in. So that's UTF-8. Let's move forward. Ipcadic. This is the character set that shall not be named. It's an alleged character set used on IBM dinosaurs. It exists in at least 6 mutually incompatible versions, all featuring such delights as non-contiguous letter sequences in the absence of several ASCII punctuation characters, which are fairly important for modern computer languages. Exactly which characters are absent varies according to which version of Ipcadic you're looking at. IBM adopted Ipcadic from punch card code in the early 1960s and promulgated it as a customer control tactic. See connector conspiracy. Spurning the already established ASCII standard. Today, IBM claims to be an open systems company, but IBM's own description of the Ipcadic variants and how to convert between them is still internally classified, top secret, burned before reading. Hackers blanch at the very name of Ipcadic and consider it a manifestation of pure evil. The jargon file is a pretty good satirical source of information, so keep that in mind. And the reason I bring up Ipcadic is not so much that it's terrible. It worked well for IBM. But, for instance, I mentioned the ISO 8859-1. if you get into your PuTTY session and set the locale as 8859, you're going to find out that it doesn't work the way you want it to. Things don't look right. Let me see if I can find the PuTTY session on this guy. Here we are. Let me bring this up real quick. Let's do appearance, behavior, translation. Here we go. Notice remote character set. If I say ISO 8859 and I connect to something where the locale is set to UTF-8, it doesn't work right. And that's just because there are so many different ways that this can be done. Notice the character sets that are available here. One of which you won't see is ipkidic. So there you go. Anyhow, that's just something to keep in mind. So again, the reason I bring up ipkidic is not so much that it's a pain or that it's wrong. It's different. And if you don't know the locale of the image you're using, you can end up going sideways. Let me exit from the CentOS image and get back to my image. So this is my Ubuntu image. Do a uname -a. You see I'm on Brownsburg and it is an Ubuntu image. I issue the locale command. Again, I'm in UTF-8. That's by default. So that's the reason we use UTF-8, and that's the reason we insist on using UTF-8 and not the other character sets. So I think at this point I'm going to end part 1. We'll start with part 2, searching and substitutions, in the next segment. We'll talk to you in a couple of minutes.